Okay, so we've got some electrophilic substitution mechanisms to have a look at here. In this case, the chemist is investigating the chlorination of methylbenzene and finds that the methyl group has a 2,4 directing effect. 4-chloromethylbenzene is one of the products of the chlorination of methylbenzene. Outline the mechanism for the formation of 4-chloromethylbenzene from methylbenzene and chlorine in the presence of the catalyst AlCl3, and show how the AlCl3 behaves as a catalyst. So let's just look at a few important points in the question. First of all, you're told that the methyl group has a 2,4 directing effect. So that means that the methyl group is going to be directing any substituent functional groups onto either carbon 2, which is here, or carbon 4, which is here. Okay, so or that one as well, 2,4,6. So we say in essence that the methyl group is activating the ring, is activating the benzene ring and allowing increasing the electron density around carbons 2, 4 and 6 to allow our groups to bond onto those points there. So what's going to happen here then? We're told in the question that 4-chloromethylbenzene is one of the products, and we need to show the mechanism for the formation of this. So watch out for instructions like that on these mechanisms, because you have to draw your mechanism to show the chlorine going onto the right carbon, otherwise you're not going to get all the marks. All right, so in this case we're going to be showing the chlorine being put onto the bottom of the benzene ring here onto carbon 4. So outline the mechanism and show how the AlCl3 behaves as a catalyst. So this is your first port of call here then for this mechanism. You're going to have to show, first of all, how we form the positive chloronium ion, which will be used then as the electrophile, and then finally, after you've done the curly arrowy bit, show how the AlCl3 reforms, hence it's shown behaving as a catalyst. Okay, so let's show the formation first of all of the chloronium ion. What happens here is our chlorine molecule, Cl2, will have to react with our catalyst, AlCl3. That produces your positively charged ion, the Cl+, and an AlCl4 minus. Do not forget your charges, otherwise you're going to lose marks. So this is my electrophile. This is what's going to be doing the business in the mechanism. So if I start to draw out the mechanism bit now, I'm starting with methylbenzene. So make sure you draw it as per the diagram. It's very often, very common what students do, because you learn this mechanism based just on benzene, and if you've been given a specific molecule to show the mechanism for, you've got to show the specific molecule. If you forget the methyl bit, you risk losing marks. So make sure you show it. Okay, so I'm going to put it in there exactly as it's been drawn. It's a bit of a mixture there of skeletal and displayed formula, so that doesn't really matter at this stage. So here's my methylbenzene reacting with the Cl+. Okay, the Cl+ is my electrophile. It's an electron pair acceptor, so electrons will move out of the benzene ring and onto the chlorine ion, the Cl+. So I'm going to get a curly arrow in that direction. Remember, your curly arrow always shows the movement of a pair of electrons. So electrons are moving out of our delocalized system onto the Cl+. That's going to produce an intermediate. Draw your benzene ring back out again. Put the CH again. Don't forget to put the CH3. It's there to start off with. It's not going to disappear. And the substitution taking place is not with the CH3. That is not going to move. That is going to stay exactly where it is. The substitution is going to take place on carbon 4 as per the question. So here I'm going to have my pitched battle between the hydrogen and the chlorine. Okay, the chlorine is trying to substitute its position for the hydrogen atom. All right. So that must mean then that the reaction is taking place here. So the delocalized ring has been disrupted. You have your U shape. In this case, it's upside down because you have to have it open facing wherever the reaction is taking place. So if the reaction is happening here, you draw your U shape that way. If it's happening there, you draw it that way. So make sure it's open to where the reaction is happening, and put your positive charge in there as well, because the electrons have been moved from the delocalized system onto the chloronium. Okay, so there'll be a mark for this drawn correctly. You then obviously have to show what's happening to allow the benzene ring to restabilize. Electrons will move back in from the bond to the hydrogen, because this is the one that's going to be replaced. So show your curly arrow going back into the system there. And then your final product, which is now your chlorinated methylbenzene. We've still got the CH3 at the top and the chlorine at the bottom, and the hydrogen has been left over So we also therefore have a hydrogen ion. Do not forget that. It's so commonly done, and that drops you a mark. Okay, you tend to get marks for this one, for the curly arrow here, for the intermediate, the curly arrow going back in, and the products. Do not forget the hydrogen ion that's been replaced. Okay, so now we're going to do a final equation to show the reformation of the aluminium chloride, because this is a catalyst. So in essence, what you're doing is tidying up the leftover ions. You can't be left over with ions doing nothing. They will react with each other. So what's going to happen? Your hydrogen ion is going to react with the AlCl4 minus ion, the two leftover bits, that one there and that one there, will react with each other to reform the AlCl3 and your non-organic byproducts. Look what's left over. So if this is going to drop in from AlCl4 to AlCl3. There's a chlorine left over. Okay, my hydrogen ion is still there, so the byproduct is HCl. Okay, so the overall equation, there isn't a mark for this, but whilst we're on it, you can obviously derive the overall equation then for this reaction, which you can see is going to be the methylbenzene reacting with chlorine, producing your chlorinated methylbenzene, your 4-chloromethylbenzene, and HCl. That's your overall reaction. Okay, there we go. So mechanisms, fairly easy once you've clicked how they work, and once you remember and realise what they're showing you. They're showing you how a reaction is happening. So remember this direction, the direction of the arrows, remember the detail, make sure the arrows are starting and ending in the right places.